Hello, and today we'll be talking all about modeling functions, and I will show you two examples, one of which is going to be exponential, and it's going to be about population, and the easier one is going to be linear, and it's going to be talking about distance. So the first one is linear, and the situation we have at hand is that boat A travels at 24 kilometers per hour, and it starts at 3 p.m. Boat B travels at 25 kilometers per hour, but it starts at 3:10 p.m. And to do this, we have to find when does boat B catch up to boat A, when do both boats reach 100 kilometers, and is there any other way to solve this problem? All right, let's start with question one. Question one is, when do the boats catch up? To do this, first of all, let's establish the functions that we were going to use for these equations because we're modeling functions. So let's say distance based on time of boat A. That's how we're going to define it. Well, it's just 24 kilometers every hour, so every t, where t is an hour, and it starts at 3 p.m. Boat B, on the other hand, it moves as 25 kilometers per hour, but it starts 10 minutes later. And since our t is in hours, we have to convert the 10 minutes into hours. So that's going to have to be t minus 1/6, because 1/6 is 10 minutes of an hour. And why is it minus? Well, if you imagine a graph that goes like this, and you have boat A that moves like this, boat B has a steeper slope, but it starts later. So it has to be, its y-intercept has to be negative, right? And the reason why it's in brackets is because 1/6 is just the time, but we're modeling distance, right? Our y-axis is the distance, and in order to get the distance, we have to, well, multiply the time by the speed, which is 25. Because in this problem, it's at constant speed, and this can be simplified to 25t minus 25/6. So when does boat B catch up to boat A? Well, that's just the intersection point. That's just when the distance traveled by boat A equals the distance traveled by boat B. And this is just simultaneous equations. So we have the equation for boat A, and we have our equation for boat B. And this is a really simple, we just have 25/6 equal to t. So this is in hours. And this doesn't really tell us much. 25 hours over 6. Yeah, I'm not sure what that means. If we convert it to minutes, so if we times it by 60, we get 250 minutes. Now, people don't really talk like that, but this is more precise, I guess. Or you can just roughly say that this is 4 hours. So after 4 hours, boat B catches up to boat A. All right, for the second question, we're trying to find out what time do both boats complete 100 kilometers. So for boat A, we can set 100 to equals 24t, and then we can have t equals to 100 over 24. And this is going to equal to around 4.1/6. So after around 4 hours, we can say. For boat B, 100 is equal to 25t plus 25/6. So this is going to be 100 minus 25/6. All of that divided by 25. And what this would equal to is around 3.8, well, it would equal to 3.83 repeating, which is equal to around 3.8 hours, we can say. So here we can see that boat A reaches 100 kilometers after 4.16 hours, but boat B reaches it only after 3.8 hours, which is pretty much faster. And for the third question, they asked us whether there's any other way to solve this problem. If you look back at how we went about this, we basically used the clock of boat A. We said that boat A starts at 0, right? Now that's not what we had to do. it could have been that we made boat B start at 0 and we had something like this, and then boat A would have went something like this. So boat A would have started at a time that's negative, we could say, and then when boat B was only starting, it would have already covered some distance, its y-intercept. And if we do that though, all of our answers would have been slightly different, because instead of having boat A be our bottom line time and everything, all of the values that we have, they're after boat A started, right? For example, boat B reaches 100 kilometers after 3.8 hours of boat A starting, right? So in reality, this takes into account those 10 minutes that boat B is doing nothing, right? Or 4 hours. It reaches 4 hours. Well, boat B overtakes boat A after 4 hours of boat A moving, which this is really subjective. It depends whose clock you're using. All of the answers that I have are in terms of boat A's clock, but you could do this problem differently, like I showed over here, and then you could use boat B's clock, which would give you different answers. All right, now let's move to our second question, which is going to be exponential and about population. So the terms of this is that the population starts, when we're starting to measure it, it starts at 36 million, right? And then it goes by 1.25% annually, so each year. And what we're asked to find is the function for the population after X years. What is the population after 10 years? And to interpret the y-intercept. Starting with the first question is finding the function for this. So let the function be defined as P, capital P for population, after X years. And we start at 36 million, right? And instead of writing 36 million, I'll just say 36. And then you would have to specify that this is 36 times a million, right? Your population is expressed in millions. And then you know that it grows by 1.25% each year. Now, I know how to write this right away, but just to show. So what this would mean is that, for example, at year 1, you have 36 times 1.0125, right? Then at year 2, you have 36 times 1.0125 times 1.0125, right? Because you're always adding on 1.25%, right? 1.25%, and you're keeping the 1. So each time you're timesing your previous number by 100 and 1.25%. And how we can express this in function terms is 36, your starting number, times 1.0125 to the power of x, right? This makes sense. So this is going to be our function that we're going to be using to answer the following questions. Our second question was, what is the population after 10 years? So in this case, 10 years is just when x equals 10. So population of 10 is equal to 36 times 1.0125 to the power of 10. And if you do this on the calculator, your answer will be approximately 40.76. So what this means is the population will be equal to 40.76 million. Don't forget about the units we're using here, right? And then our third question asks us, what does the P or y-intercept imply? Well, think about it. What is the y-intercept? Well, the y-intercept is when x is equal to 0, right? So in our case, when x is equal to 0, that's year 0, right? And what is year 0? Well, year 0 is just the initial population. So what the y-intercept or the p-intercept implies is that that's the starting population. And I know I've said this a couple of minutes ago when I was reading the problem out, but it's really important that you understand the key components of a function. For example, the x-intercept, the y-intercept, and so on. and what they really mean, so you know what the function is. Alright, so those were the problems that we had for today, and I hope you got a bit more comfortable with modeling real-life problems using functions, and I hope you enjoy this video. See you next week. Bye!